Swayam Prabha. Digital India. Educated India.
Hello everyone. In this lecture we will discuss about design for sustainability for optimization of manufacturing. We know in the post-industrialized world, manufacturing is one of the actually drivers of the actually this economic model around the world. Most of the countries, they want to be like the most industrialized, and in order to do so they are adopting actually technologies, ways in which they are sourcing these non-renewable materials from the nature. They are investing a huge amount of energy to process these materials and produce variety of stuff. So in the recent times we have seen in our one of the previous lectures about consumerism, where the consumerism, how the consumerism has increased over the these years, and how it has become one of the most thirsty actually area which is looking to satisfy its need, which is looking to satisfy rather its greed, in a a more in a mammoth way. So it requires a huge amount of resources, huge amount of natural elements such as a clean air, water, etc., and it requires energy. Okay, so all of it is going mostly into the manufacturing actually processes, whether it is for our a food, whether it is for our a clothing, whether it is for providing housing, or for other requirements such as for health related, education related, any of these domain specific or industry specific needs. There is certain actually a certain amount of it is coming from these manufacturing actually units. If we talk about these aviation, so we have actually aircrafts being manufactured somewhere. If we are talking about these electronics which we are using and communicating with this actually lecture right now, so these are also being manufactured somewhere. These are using actually n number of synthetic actually polymers. They are using actually number of metals, the number of other rare earth metals, and there is so much of actually effort going on into manufacturing actually these days. And in an overall sense, we have seen in the previous slides how manufacturing and how these sector is responsible for actually global warming potential GWP, how it is responsible for GHG emission, greenhouse gas emissions, how it is responsible for a carbon footprint, how it is responsible for actually exceeding the biocapacity of this planet, and how it is responsible for creating a mess in the overall ecological balance. So it is very important for us to control this actually sector and go for ways through which this can be actually controlled. So if we see about a sustainable manufacturing system, so it should work actually on the closed loop industry. Okay, so there are some approaches listed down over here on this slide, and we will see each of them one by one. So the first one talks about a sustainable manufacturing. So optimized processes that minimize negative environmental impacts, conserve energy and natural resources. This also enhances employee, community and product safety. So we see majorly the economic and environmental aspects of EAC, aspects of sustainability are involved over here. So this sustainable manufacturing has the potential to minimize the negative environmental impact, because this is one of the actually major contributors of this a negative impact on the overall ecology of this planet. And of course, by reducing the demand of energy, by reducing the demand of the resources and the materials, it can help reinstating, it can help actually at least preserving what we have in terms of resources on this planet. So, and apart from this, well, it has the potential to enhance like a, well-being of like of the employees and the other stakeholders, the community, because community and the people are important part of this sustainable actually, this whole growth and development actually process. So how this sustainable manufacturing can come to the help of this community also, and how the product safety also can be actually enhanced in the products, for like a responsible uses. For example, any like these insecticide, home based like a domestic insecticide we use in our like houses, for example, like a mosquito killer sprays or these things, so it is clearly like written on the label of these like a products that they have actually certain amount of like a poison in them and or toxic in them, and these products must be actually kept away from the like human eyes and skin, must be kept away from the like a children. So why is it so? Well, this instruction is of course there for the keeping it like a at the safer actually distance from like a humans, from like a from the people. Okay, so this kind of actually responsible, how is it like is there any way out to actually completely get rid of such like a toxic materials and substances, which takes a lot of like a effort and resources, for example, like for their manufacturing, and still they are not safe enough for like a actually in the like a vicinity of like humans and the babies and the kids. So is it possible for like a sustainable means to get rid of these like industrialized products and bring back some more like a ways through which the objective of like a insect repellent and these things can be actually taken care of? So this is actually one of the major actually considerations for like a sustainable manufacturing processes. Second, optimization of production processes and techniques. So production processes are the processes which which consume the most part of the energy required in the industry sector. So how this can be optimized? So optimize production methods and operations by continuously improving performance, production quality control, fewer production steps. Manufacturing innovations like IoT, automation, 3D printing. Lower production and labor costs and greater efficiency. Well, there is scope in each and every step of these production processes and techniques, whether we are talking about the machinery what is being used over there, what if we are talking about the whole technology part, like if we can go for the much safer actually, or much actually less consuming like a technology for like energy and resources. If we go for like a newer technologies such as like IoT, automation, and 3D printing. So 3D printing has immense potential, which can be like a still utilized, which can still be like a explode in n number of ways to go for like a sustainable actually manufacturing processes. So 3D printing, as we know of, is like a additive actually manufacturing process, where the waste of the material is minimized up to like a greater extent, and it doesn't actually waste like a material. For example, when we construct any like other like a artifact from a piece of like a wood or metal, we utilize actually methods of like a machining, etc. And we end up actually wasting a lot of material, from that block to carve out the particular part what we wanted. For example, if we want a kind of maybe some object, so some object we can actually sculpt from that actually block of the material. So this 3D printing actually prints that entity only whatever we wanted, removing completely the rest of the wastage actually part, which usually the this reductive actually fabrication method, actually reductive this construction method actually uses. So we see like there is a huge potential of in these actually technologies to be applied in our like a design and construction actually exercises. So utilizing these new technologies could also be an like a strategy where actually we can use such like a techniques for like a greater efficiency. So this could be used for like a even reducing like a labor cost, even reducing the time consumed in like a fabricating these like a products or constructing these projects. So time is also one of the major considerations today, which we can actually optimize on. So we are talking about in the next level about increased energy efficiency. So this low and clean renewable energy consumption, minimize energy uses in production. So this energy is one of the very important entities today for the which has come to the actually help of this whole entire like a growth and development model. So, and we are aware of like a building sector itself consumes around 40% of the total energy produced in the entire world. So this is the largest and the major share which this sector actually has grabbed. So how this energy consumption can be minimized? So this is also one of the actually important strategies which we can adopt for the overall actually sustainable achieving these goals. Further, like producing less pollution, emission and waste. Of course, there is a lot of mess which has already happened in the entire ecosystem, in the air or water, earth, and most of these places. So how this can be actually minimized, how the these resources should be actually taken away from becoming a polluting or toxic agent in the nature. I think that should be the focus of like a today's actually design exercise. So like producing like a low waste disposal materials to reduce the these costs of which are happening due to the pollution, cleaner and safer working environment, so creating actually places, comfortable spaces where one can actually work in like a healthy environment. So one of the actually SDGs like a target is to create actually maintain the health and well-being of the like a community also. So how this point can help in that SDG also is very interesting to see over here. Further, industrial symbiosis emulates sustainable natural cycles in industrial networks, where all discarded materials from one industry become actually resource for the others to use. Industry 4 actually production systems, prototyping new manufacturing setup. It talks about two major points over here. The first one is to close the actually a cycle of any like a product. So if there is any like a byproduct or any like a waste material, so a process should be developed so that that actually waste or that actually byproduct, okay, should become a raw material for the some other actually process. Okay, that is why that is how actually we may be able to close the loop. So this is one of the very important actually aspects mentioned over here, like to go for like an industrial symbiosis. Further, like industry 4 production system. So industry 4 actually this uses a lot of integration with the like IoT, internet of things, and other like networks, and this 3D printing and several like these AI ML based actually calculations and algorithms. So with the incorporation of like a high degree of these emerging actually technologies, how the efficiency can be actually achieved is the matter of discussion over here. The last point over here is like a design for remanufacturing. So disassembling into like a useful parts so that it can be directly reused into another product. Improvement around actually its assembly, repairability, refurbishment, disassembly. So this we have these points we have discussed in the 3 R's chapter. Okay, so why it is very important for designing for the like a disassembly, designing for actually dismantling, designing for remanufacturing, designing for reuse, because of this disposal and the actually throwing of any like as simple as that, throwing of any material into the nature, without actually properly disposing of it is a crime which we are actually committing with the nature. So this must actually stop at the urgent basis, and we must actually design each and everything which should follow one of these approaches, one of these actually strategies in order to minimize impact. So let's move to the next slide over here. So how this manufacturing optimization can be actually brought, and what could be the actually benefits out of this exercise. So increased machine and people utilization, increased machine and process output, and decreased time to resolve faults, decreased operational process buffers, decreased instances of recurring problems. So you see like there are several actually benefits of this process optimization, this manufacturing optimization in the like a manufacturing sector. So there is always like an efficiency which can be actually brought, whether it is on time, whether it is on resources, whether it is on energy, whether it is reducing the number of instances of failure and repairability, etc. So well, there are advantages only overall which can actually result into benefit actually for the like a country. So the processes, if we see of the like a manufacturing optimization, so here we can see like a specify the required visualization and system integration with the enterprise system, align the digital twin with visualization and integration to provide the required information. Third, tune the analytics algorithms to generate the status and insight information required for the digital twin, and add data sources to support analytics. Modify and create data sources to provide the required data inputs to the analytics. Extend IoT infrastructure as required with gateways, sponsors, etc. to generate the required data. Finally, provide manufacturing optimization as a fully managed service following an initial POC. So you see like how this thing can be done. It's not very complicated. It's not very actually a rocket science, but yes, with like a proper intent, with a justified intent, with a actually pious intent, and some efforts, this can be easily done. And this would certainly will lead to this optimization and achieving actually efficiency on like a several actually fronts. So how these waste reduction strategies can also be formulated around this actually manufacturing like a processes. So we can see in these many efforts, starting from the raw material, accurately measure before insert in the production line. So as simple as that, it's not something very difficult to understand. So the wastage of the material can be minimized right there when we are actually giving the input of that material into the actually manufacturing process. Secondly, on the process optimization part, minimize the product various of like a product measurements, increase robot depends on the processes, implement quantity is centered at process stages, analysis waste data product wise, process wise, machine wise to identify waste types and maximum actually waste generator. Finally like a test sample from like a batches, or lot before starting like a mass production. So these are also very small and easy to understand finer points which may result into better optimization of the process itself. On the maintenance side, if we see like verify machine wise, unit wise data and perform maintenance task at maximum waste recorded. So if we have this data like how much was the maximum waste generated at any given machine at what capacity, then we can go back and re-engineer this to minimize the actually waste, so that there is a very little actually output on the like a waste part. Second, like a prepare schedule to focus maximum waste generating areas machines. Third, like replace parts equipment cause generating causes product various deviations, etc. So these are actually final points. Over here we can see about like how this maintenance can be taken care of by going for like a repairs, going for like a preventive checkups, etc. of the like a system. Finally, on the monitoring and control part, improvement of quality control and process monitoring, inspection of lot by lot to avoid like a mass product inspection, and third, monitored area or product immediate reporting to concern to easier for like tracking actually the issues. So you see on this monitoring and control part also, there is a lot much which can be done, and this is actually final stage where some more actually quality control and quality checks can be brought in to minimize the actually return to actually factory of the faulty and defective products, resulting into like a saving of a lot of like resources, material, time and energy, etc. So on all stages of this like a production, if we adopt like a waste actually reducing like a strategy, so there is always like an immense possibility to improve on these actually factors. Finally, on the like a process optimization, we can go for like the mapping of the entire process. We can go for the process identification, identifying which process to improve. We can go for actually footprint and planning, etc., developing your own plans and define source footprint for the manufacturing actually floor analysis, documentation, design, results analysis part. Okay, and then finally like the lean manufacturing, accountability and sustainability at plant entry level, and improve plans for the cost. So these are very standard actually typical procedures for like any optimization processes also. Okay, so by complying these with these actually measures in like at the like a high degree could result into optimization on the manufacturing front. So here if you see on this slide, so this slide talks about this fashion in like a cyclic way. So how the sustainable manufacturing leads to like optimization of like a processes, production and techniques that will lead to the increased actually energy efficiency of the like overall actually demand which that industry unit is actually putting up, finally resulting into like a producing like a less pollution, emissions and waste, finally like establishing an industrial actually symbiosis and design for like a remanufacturing again, like we should actually be able to handle like our like byproducts and the outputs, that so that they become actually part of like a cradle to cradle actually approach, and then we can again go back to starting like a sustainable manufacturing. So this we can close this circle and complete the life stages of any product into a complete like a closed actually circle. Coming down to the next part, this is actually a model given over here for like a applied industrialized like a AI in manufacturing sector. We will discuss one by one. So this is divided into like a 4 columns over, you can see over here. So first one belongs to like a monitoring and predict failure, second in the improve production, third is for like augment production like design, finally like a automate operations. So in these stages, what could be the strategies for like a improvement which we can adopt for the overall actually efficiency, to increase the efficiency in the manufacturing sector. So here we are talking about like a reducing cost. So reduce actually equipment cost, increase like equipment into utilization, so that will result into obviously like a reduced cost for the overall like a system over here. And you go for the actually predictive maintenance. Okay, beforehand, before actually the system goes for the failure, we must actually undertake preventive maintenance, in order to reduce the idle time and in order to actually minimize the actually waste of the time factor, of these like a heavy like a priced machineries. So for that, improve in the second column, for improving like others production system, we can go for improve production quality by decreasing the development cost, by improving the efficiency, increase safety measures, reducing the defects, and on this predictive maintenance part, there are 3 points given over here: predicting overall equipment effectiveness, predicting production quality, predict safety risks, which will in turn again like further give actually this actually lead to the optimizing like a production. These two are leading to the optimizing production. This second one is leading to optimizing like a supply chain and optimizing like a staff allocation. So we see like there are three like a further like effects of like taking these this predictive actually maintenance activities. So in this augment production design, so we can increase actually efficiency of the entire this machinery and this equipment, set up the equipments and tools being used, and also increasing like a production capacity. This way we can actually reduce the material consumption also. Finally, in the automate operations part, create market differentiation, customize production, increase innovation. So with these actually this initiative of this predictive maintenance as a resultant at this stage, we can actually go for checking the real life actually supply chain. Further we can go for like a real time production planning, and we can overall, in an overall sense, we can simulate the design, and we can actually rework our if there are any like a lacuna or any like a shortcomings. So in an overall sense, if you see in this yellow part, 30% or less of total potential data value is realized by most manufacturers. So in terms of the data like a kind of a is shown through these like a columns over here, like how much of potential is available in each of these actually columns. 60 monitor and predict of a failure. So the 60% of like a wasted expenses come from unnecessary operation and maintenance costs. So how these costs can be actually minimized, so this is one of the actually opportunity areas where there is a huge scope of like improvement. Further, for the improvement of production, 20 to 30% actually increase in delivery reliability can be actually attained through these measures which are happening in this actually column. Further, like for the augmenting production design, 80% of manufacturing costs are affected by decisions made in the design stage only. Okay, and next, like augmenting actually production design. So 7% potential reduction in working capital. So see, these are actually they are not actually small numbers if we consider the volume of actually resources and energy and things utilized by these sectors, or in overall actually output. These quantities will be immense, very huge. And here we see the kind of amount, the kind of figure we are seeing over here. This is talking about like 80% of manufacturing costs are affected by decisions made in the design stage only. So design stage is very critical. Design stage is very important actually, how things are going to turn up, in the like operation stage. So we must actually take care of these design stage in order to minimize the risks involved, which may occur, which are in the tune of like up to like 80%, which is immense. So finally, in this stage, if we see for automating actually operations, so 20 to 50% potential reduction in defects through like a simulation and testing, which is also huge. First of all, it adds to the like a customers like a confidence in the product, whatever is being manufactured. It increases the actually brand value. Plus it helps reducing the costs of like a repair, replacement, and refurbishing, etc. So helping into like a minimizing the overall actually consumption by the like a company. Finally, like for automating operations, we can see 50% potential decrease in product development costs also possible through actually automating the operations. So there are a lot of like improvement areas we saw actually through this slide, in a like a manufacturing sector. Further, see this next table over here. This talks about applied industrialized AI in healthcare sector. So how this AI is going to help for this healthcare, we will see this table one by one. So the first column suggests about monitoring and predicting patient outcomes. So improving like operational efficiency, reducing cost, and increasing capacity, of course. And one like a hospital length of stay, if you see from like this stage in the like a second column, so we will see like optimizing the column talks about optimizing staffing and quality of care. So improving quality of care, improving like availability of care. So with this actually hospital length of stay, admission forecasting, like how many actually number of patients or intakes will be there, will be happening, and then planning the staff actually members for like an optimized actually working in an efficient way. So this will lead to certain like a chain reaction in the next actually column. So here if you see in the augment diagnosis stage, increase the effectiveness of care. So the improving like a pricing, improving like a diagnosis, which will result into like a with these initiatives like a cohort discovery and predict readmission risks, like if there are any. So this model actually helps in understanding like what are going to the conditions of the patient, and in what ways like the hospital may have to deal with them if situation like improves, or if situation doesn't improves, if they need like a readmission or something. Okay, finally in the fourth column if we see automating intervention. So automate intervention part like a personalized medicine, better patient engagement, so that customized actually medicinal services, customized actually medical service can be extended to the patients. So with these actually effort of these activities, engaging with the community will increase, and in turn it will actually prevent unplanned hospitalization. It will end up into an increased actually well-being and betterment of the like a patient and the community in overall sense. So in the numbers if we see like a monitor and predict patient outcomes, so the 8% potential reduction in the healthcare expenditure is like expected through this actually modeling. On the monitoring and prediction patient outcomes, like 2 to 4% of annual claims are fraudulent or unjustified. So this also can be actually prevented. Further, like a $200 like a potential saving per person due to increased like a productivity. So this can be achieved through like optimizing staffing and quality of care. Further on this, like a 30% potential annual productivity growth can be achieved. Further on to the 60 to 70% of hospital cost consists of like a staff labor. So this can be actually minimized significantly, or at least optimized for like a better output. So this modeling would be very helpful in actually optimizing the staff of the like a hospital. Further, on the augment diagnosis, 40% potential reduction in adverse drug reactions, 30 to 70% cost savings by reducing the prescribing of ineffective drugs, and 25% on average are like readmitted within 30 days. So this also can be prevented. So this is actually a help through this predictive modeling, like how hospital can plan its resources, resources of the availability of beds, resources of the staff, doctors and nurses and other caretaking persons, for increased efficiency. Finally, on the automated intervention, the column over here, we can see like a 1 year potential increase in life expectancy because of personalized care. So this is a one of the way, like huge achievements which a medical actually fraternity can give to the humanity right now, like an increased actually life actually potential. So we have been seeing with the improvement in the health sector over the last several decades and the last century, like how much of the life expectancy has actually increased, and further these modelings and optimization actually processes will boost this figure up. In the next and last slide of this actually lecture, we will see about this applied industrialized AI system in the public sector over here. So in this the public sector, we have again these four columns, so we will try analyzing these. So on the first column talks about monitoring and predicting infrastructure failure, reducing waste, so reducing infrastructure costs, reducing staff costs, reducing resource costs, so these are actually measures which can be taken up for a further improvement, like detecting fraud, if it is happening at certain level, predictive maintenance, and ITSM. Further, in the next column, if we see optimizing staffing and resource availability, improving efficiency, increased staff utilization, increased infrastructure utilization, increased resource availability. In the next point, if we see with the help of these points undertaken in the previous a column, we can go for actually service demand forecasting. So these actually productive modeling, this projection can be actually drawn for actually creating a model for a demand forecasting, which are going to actually happen in the a public sector. Okay, and resource demand forecasting, yes. The third column, if you see augment policy and resource allocation decisions, improve the effectiveness of policy, improve staff allocation, resource allocation, citizen satisfaction in an overall sense. So this model, this actually predictive these steps will lead to optimized resource allocation, staff allocation, or citizens a sentiment. So then improved actually efficiency of this infrastructure, and the repairability and maintainability will lead to the the positive impression in the mindset of the community and the public at large, improving the actually the image of the public sector. Finally, in the fourth column, if you see, this is about automating review and administration. So here we are talking about improving public service quality, decrease response time, increase accuracy and consistency. So these are actually two major actually areas of concern as far as a public interaction is concerned, because the service must be actually rendered within the satisfactory actually time limit for the persons to feel that yes, they have been taken care of, their problems are actually addressed, and secondly increasing accuracy and consistency, so there is minimum chances of error or mistakes happening in the entire system. So with this we can see in this stage automating administration and decision making processes, so that efficient way these things can work actually. Finally, in the numbers we will see in an overall actually sense, 90% of public sector administration data is born actually digital. Monitoring and predict infrastructure for 15 to 20% potential reduction in the cost of administrative activities are possible through this measures for detecting fraud before and going for predictive maintenance, etc. Finally, in the second column, optimizing staffing and resource availability, 15% potential redeployment of the administrative staff, 20 to 25% potential savings in government operating budgets, are possible. Further, like if we see like a 0.5% potential growth in annual productivity can also actually take place. So considering the huge budget and amount of actually investment needed for maintaining and executing these infrastructure projects, smaller like really improvement in the overall optimization of like a, at the scale of like 0.5% also will result into saving in the like a multi like a crores of rupees, and the money invested in the public sector. Next, 15% actually potential increase in citizen satisfaction level also with this improved actually transparent actually processes as far as like the when the public interaction is concerned in the public sector. Finally, in the fourth column, 20% potential reduction in administration error is also possible. Avoiding actually such like errors and mistakes, through this AI modeling, and 30% average potential savings in the administrative cost of like awarding contracts also is possible, because this is one of the key areas where this public sector awards actually contracts to the contractors who execute certain works. So these this system will also help further optimizing the overall actually ecosystem in the like a public sector. So we understood through this lecture like how this process optimization, how the optimization in manufacturing, how the process optimization can help in reducing the resource consumption, in reducing the energy cost, in optimizing actually the resources whatever we have to the maximum like a potential, in order to minimize the impact on the ecosystems. So we must actually use these methods of like optimization strategies in our like designs and in our like a system design projects to improve on the overall efficiency. With this, I would like to bring an end to this lecture. So thank you everyone.